The biggest problem with studying stars is their distance. They're just so far away, we haven't got a chance of going close up to have a look at one. The only way we can find out about the stars is by gathering the light that arrives from them. And to do that, we use telescopes.
Light is crucial to our understanding of the cosmos. At first glance, all the stars may appear the same, but take a closer look at the constellation Orion.
The top left star in Orion is called Betelgeuse. The bottom right star in Orion is called Rigel. If you look carefully at those stars, you'll see that Betelgeuse is really quite red, whereas Rigel is really quite blue. Now actually, that difference is because they're different temperatures. So the colour of a star can actually tell us its temperature.
Somewhat counterintuitively, red stars are comparatively cool, while blue stars are hotter.
Just looking at the visible light from the stars gives us a huge amount of information, but it's not all that there is, and in fact there's more that we can find out.
Visible light is just one part of the electromagnetic spectrum, but there is a huge amount of light out beyond the red and the blue that we just can't see, such as X-rays, infrared and radio waves, and with telescopes we can open the window on this invisible universe. Telescopes like Jodrell Banks' giant 76-metre Lovell radio telescope and ESA's Herschel Space Telescope, which can see the sky in infrared.
When we look at things in infrared light, we can get extra information on top of what we can see when using visible light. So let's take these 2 cups of tea, for example. In visible light, they look virtually identical. Be hard pressed to tell them apart. When we look at them in infrared light, such as with this special camera, we can see that they look very different. So the one on the left appears red, and the one on the right appears blue. And that tells us the one on the left is warmer than the one on the right, which is quite useful if you actually want to go and drink a cup of tea.
Using infrared and radio telescopes also has other advantages.
If we had eyes that were sensitive to radio waves, if we had little radio dishes for eyes, and we looked up now, we'd actually be able to see through the clouds. We can do radio astronomy during the day as well as at night. We would be able to see right through the clouds now, straight out into space.
Telescopes like Herschel can also allow us to overcome one of the biggest problems astronomers face: dust.
Dust is the bane of an astronomer's life. It's not the same as dust in a house. Dust in a house is basically a lot of it's dead skin and so on. But dust in astronomy is tiny grains of carbon and silicon. So it's a little bit like sand in that kind of sense. If you look up at the night sky on a clear night, you may well see the Milky Way stretching across the skies. But all along its length you'll see there are dark lanes, and these are dust lanes, and it's dust that's blocking our view of the stars that lie behind. What we know is that behind those dust lanes there's a lot of interesting stuff going on. That dust, in a few tens or hundreds of millions of years, some of it will become new stars. Those stars that are currently in the process of forming are currently shrouded by this dust, and we simply can't see through using visible light. Imagine I'm looking out into deep space, and I'm looking at a dust cloud that's black in visible light. I can't tell anything about it. It's obscuring anything that might be going on behind. Well, to see what's going on behind, we need to look at infrared wavelengths. We can use our infrared camera, and I can point at the cloth and we can see that in the centre there's a bright yellow splodge. And that tells us that in the centre it's a lot warmer than it is around the edge. And this is very analogous to what Herschel does with dust in space. The dust might be much cooler, but the dust is being heated up by, for example, stars behind. So from this I can infer that there's something behind the cloth, or the dust, that's heating it up. So it's got to be something hot, and it's probably got to be something bright as well.
Using infrared light, Herschel will reveal some of the secrets about how stars form inside these giant clouds of dust and gas.
Each of these views of the universe gives us a different piece of a jigsaw, and when we put those pieces together we get a complete picture of the object that we're studying.